so with any function, and we looked at this with linear functions, it just makes a little bit more sense now, and you can see it a little bit better when you look at transformations of the quadratic function, which is going to be this time it's either going to be a horizontal or vertical shift based on what the equation has given us or based on our graph there. And so we're going to take a look at those real quick. So here we have transformations, and we're just going to look at H and K. So they're going to shift right and left or up or down. And so what we have here is that you can see that H is inside the parentheses. It's closest to X. The X-axis is horizontal, so that is going to affect your right and left. So H is going to affect, is going to shift right or left. Now, this is where it's a little bit backwards, because if it's minus H, if it says minus H, it's actually going to shift to the right. Sometimes I have to really think about that. So if it's a minus, that's what's going to tell you to shift to the right. So it's backwards. And then this is to the left. Now, how I think of this is that you see those parentheses, it kind of looks like the H is in jail, they're in trouble. And so they did things that were backwards. So that's kind of sort of how I think of it. I know. So if they're in jail, then they are backwards. They do things opposite. And then K is outside of the parentheses, farther away from X. This is going to be a shift up or down. So this one, since the H is not inside the parentheses or the jail, then it's going to follow the rules. It follows the rules. That's why they're not in jail. So the plus is going to be a shift up, and then a minus is going to be a shift down. I don't know why I keep writing shift. There we go. So if it's inside the parentheses, that means it does not follow the rules. That's why they're in jail. And if it's outside, then it does follow the rules as far as plus or minus goes. Just, I say rules, I mean rules that we have in our head for how plus and minuses work. So let's take a look here. So now you're thinking, well, how do I know where it shifted from? Okay, that's a great question that you asked. So remember that we had a linear parent function. We have a quadratic parent function. So the parent function is y equals, or f of x equals, remember that means the same thing, x squared. So when we look at the quadratic y equals x squared, it's going to go through the origin, and it's going to, right now, that's all that we need to know. And it's also going to be open up. So it's going to go through. So the vertex is at 0, 0, and it also opens up, which means it's going to be like a U shape. So if we have our graph here, okay, so what we have here is we are going to, our origin is here typically for the quadratic, and it looks something like this. I'm like really rough sketch, sorry about that. So it looks like that. So you can see that from the black graph that I drew to the left, that is going to shift to the left 2. Okay, so that's going to affect H. And remember that we are going to write that as X. And instead of saying minus 2, remember that's right or left, it's going to be plus 2 squared. So to write this function, it would be x plus 2 squared because I'm shifting to the left 2, okay? So you can see it's shifted to the left, Even though we said plus, remember, inside the parentheses, don't follow the rules. All right, so if you look at my second example here, you can see here, I'll go ahead and graph this a little bit better. There's my quadratic parent function. What really looks like here is that the red is a little bit wider. It's really not wider. It's really just shifted down. So this is really going to be this is really shifted down 3. And so therefore, I'm going to have y, or f of x, equals x squared minus 3. So notice that the difference between those two. So if it's inside the parentheses, it's going to shift it right or left. If it's outside the parentheses, it's going to shift it up or down. So it's kind of sort of based on those two. So that's just a single transformation, just a single shift. Either we have left and we have down there. And then let's look here. So now we have an equation, and we need to identify the transformations to the quadratic parent function, which is y equals x squared, based on this function. So remember that we have y equals x squared. That's our base. And then we can see that, oh, we have this +4 is added and this -6. So remember that the +4 is inside the gel, okay? And so it does things backwards. It doesn't follow the rules. So it's not going to shift right. It actually, that is going to be a shift left 4. So it's going to shift to the left 4. And then that's what this part does here. And then the -6, that one's outside of the gel, so it follows the rules. That's going to be down 6. So you can have 2 transformations here, or you can just have 1 transformation based on what you're given. So the big key thing is knowing which way it's supposed to shift, right or left. Up or down is really easy to remember because it just follows those rules. But if you can think of it, being in the jail doesn't follow the rules. That's why they're in jail. So shifting up or down. That's kind of sort of how I think about it. But if you can think of a different way, then by all means do that. This is a great thing that you can put in your calculator. Remember, you want to put in y equals x squared first, and then in the second one, you want to put in your transformation and look to see how they've shifted or changed there. So that's another key thing, or just another tool that you can use to look at these transformations. So these transformations are just going to be up or down or right or left. And that's it.